In this video, we have equations with multiple logarithms, and our goal with multiple logarithms, when you have an equation that has more than one logarithmic term, we're going to want to either get it into the form on the left, so form number one where you have a log equals a constant, or we're going to want to get it in the form on the right where you have one logarithm equals one logarithm. And when I say one logarithm, I literally mean it has a coefficient of 1. So there's a coefficient of 1 in front of each logarithm. And there's only one logarithm on the left and only one logarithm on the right. If you can get it into the form, like the first form, then you'll be able to use the property that we used before, the procedure that we used before, where we were writing it in exponential form and log form, depending on whether or not we had an exponential or log expression. If we get it into form 2, sometimes that's even a bit easier, because if you can get it into form 2, then x equals y, then the arguments equal each other. So this is really super important, that if you can get it into form 2, exactly like form 2, one logarithm equals one logarithm, then you can set the arguments equal to each other. But it is an important note. It is a very important note, because this is a very common misconception with students, is that they think that if you have multiple logs in your equation, you can just cross off the word log. And that is not true. That is not true. You cannot, I'm going to do this, I'm going to underline this in red. You cannot just cancel out logs. You can't do it. Only if you are in form 2 can you set the arguments equal to each other. So in example 3, I'm going to model form 2 for most of these, because most of them have not just 2 logarithms on one side, but they have a third logarithm. So I'm going to show you that form 2 is going to work best for A, B, and C. But then when we get to D, I'm going to go back to form 1. Okay, so on example A, 3A, I'm going to take these 2 logarithms and I'm going to condense them. So remember, when you condense and both logarithms are positive, we're going to multiply the arguments. So I get 3x plus 12. So log of 3x plus 12 equals the log of 5x minus 2. Now that I've condensed the left-hand side to be one logarithm and the right-hand side is one logarithm, I can set the arguments equal to each other. So this argument equals this argument. If I'm using a highlighter and I'm highlighting more than one on the left and one on the right, likely I am going to get the wrong answer. Okay, I'm going to solve for x. I get 2x equals 24. And then I'm going to get, something happened here because this is not a 12. Thank you very much. This is a 2. I'm going to get 2x equals 14, not 24. Subtract 3x, add 2, and that gives me x equals 7. Now here I'm going to plug that 7 back in. Everywhere I see a variable, make sure that it doesn't make either argument negative. 7 plus 4 is positive. 7 times 5 minus 2 is positive. So x equals 7 is a solution. Okay, we're going to try B. This time I have natural log of x plus 1 minus natural log of 3x minus 5 equals the natural log of 7. When I condense this left-hand side, we're using the quotient rule. So we've got natural log of x plus 1 over 3x minus 5 equals the natural log of 7. Both of these logarithms are one logarithm on the left, one logarithm on the right. Therefore, I can set their arguments equal to each other. So I get x plus 1 over 3x minus 5 equals 7. And I'm going to put that 7 over 1, and I'm going to cross multiply. 1 times x plus 1 equals 7 times 3x minus 5. X plus 1 equals 21x minus 35. I'm going to get 20x on the right, and I'm going to get 36 on the left. Divide both sides by 20. 4 goes into both of those numbers, 9 over 5. When I put 9 over 5, which is just shy of 2, so I'm going to say 2. 2 plus 1 is 3, that's positive. 2 times 3 is 6. 6 minus 5 is 1, that's very close. So let's see what this is. This is 9/5. I'm going to do a quick check here because, you know, I rounded up and I want to be careful here. 3 times 9/5 minus 5. So 27/5 minus 25/5 because 5 over 1 is 25. And that is, yep, just made it. Positive 2/5. That works. Box in our answer. Okay, C would be a great problem if you want to try that one and see if you can get it. Now that you've got the process as a nice little reminder down. If not, you can watch me the entire way. Okay, I'm going to multiply those two arguments and I get x squared minus x minus 6 is equal to, and that's a base 3, log base 3 of 14. So now that I've got one argument, one logarithm equals one logarithm, I can set the arguments equal. I get x squared minus x minus 6 equals 14. I love factoring, and I know you do too. So I'm going to get two potential answers, 5 and -4. Let's make sure that both of them work. When I put a 5 back in, 5 plus 2 is positive, 5 minus 3 is positive, 14 is already positive on its own. -4 plus 2 is negative, and that rules it out right away. -4 is extraneous. So the only solution would be x equals 5. And that's the one I'm boxing. That's the only solution. X equals 5. Now, the one on the very last one that we have here, I'm going to go back to form 1. So I'm going to go back to form 1, and that's because I have this constant on the right-hand side. So I'm going to say this is the natural log of x over 3 equals 2. So when we condense it, we're using our quotient property. This is a base e. E squared equals x over 3. Multiply both sides by 3, and we get x equals 3e squared. Now I'm going to plug that back in. That's a positive number. When I plug it back into the first argument, which is the only argument that has an x in it, it's going to keep that argument positive. So that is our solution. X equals 3e squared. Now the reason I'm not using my calculator is because it says, it did not say, but it should have said exact form. So it should have said exact form. Check for extraneous solutions when necessary. Super, super important. Okay, in the next video, we are going to continue to solve these types of problems. They just get a little bit more involved, not too bad. So if you want to give those a try, you can ahead of the video and then use the video to check your answers. You're more than welcome to do that. But we'll have a video for example 4 coming up next.